All right, test 2-1, review. Okay, simplify fully. There's a negative inside of the square root, so I'm going to bring that out. All right, we can just start prime factorizing this. It's an even number, so 2, 420. 2 goes into that, 210, 105, 5, this will be 21, and 3, and 7. Okay, where are my pairs? Here. So that'll come out. And that's it, right? 2, 5, 3, and 7 don't have any pairs, so they stay inside of the radical. So this is going to be 2 square root 2 times 5 times 3 times 7. All right, 2 times 5 is 10. This is 21, so 210. So 2 square root of 210i. Okay, it's simplified fully. Actually, 1 through 6 are all simplified fully. So number 2. I'm subtracting 2 complex numbers. I'm going to distribute the negative sign. 2 minus 4i minus 13 plus. We're just combining like terms. The real part plus the real part. This is going to be negative 11. Negative 4i plus 15i is going to be positive 11i. Yep. Negative 11 plus 11i. All right, number 3. The square root of negative 12 times the square root of negative 10. So first off, they both have negatives, so I can pull an I out from both. So where I'm pulling out an I from there and an I from there. I times I is I squared. We know that I squared is just negative 1. So if I combine these, right, square root of 12 times the square root of 10, actually I don't like that. What if I 2 and 6, 2 and 3. So this is really 2 root 3. And this is going to be 2 and 5. Nothing happens there. So I'm going to do the outside times the outside. So 2 times negative 1. That's negative 2. And then 3 times 10, right? Inside times inside. So this is root 30. So negative 2 root 30. That's this simplified. Okay. That one wasn't bad. All right, number 4. So I to the 1,750th power. All right, so what we have to do is divide this exponent by 4. All right, 4 goes into 17 4 times. 4 times 4 is 16. 1, bring down the 5. 4 goes into 15 3 times. 4 goes into 30, 7, it's 28, 2. All right, so remainder 2. I don't really care about this part. This is the part that I'm concerned with. So squared. Okay. Regardless of what exponent you get, if you divide this number by 4, whatever your remainder is, wherever it lines up on here, that's what it is. So we have a remainder 2, so I squared should be -1. So this answer here is -1. Right, if I divide this by 4 and it comes out with 0 remainder, right, no remainder, that means 4 went into this number evenly, and it's this right here. Technically, I guess we could say, right, if you have a 0 remainder, if 0 happens here, then it would be this one. But these are the same, right, because it repeats. Okay, simplify fully. We have a imaginary number in the denominator, so I want to multiply by the conjugate. So the conjugate of 10i is going to be -10i. I'm almost tempted to just multiply by I. What if I multiply by I, I'll get -1 in the bottom and in the top. Well, let's just stick to this and see what happens. So, okay. Bottom times bottom, this is going to be negative, right? -100 I squared over, right, it's going to distribute -60 I positive 50 I squared, but I squared is just -1 in both instances. So -60 I minus 50 all over negative is going to get a positive 100. So I can take out a 10 from here, here, and here. So this is going to be -6i minus 5 over 10. We can leave it at that. I think we can leave it at that. That's fine for me. Okay. So I wonder here. if we just multiplied by I, right, if we just multiplied by I, this would be I squared, which is -1, so -10. This would be 6I minus 5I squared, which is -1, which is basically the same answer, right? This negative, and in the last answer, it was in the top, right? These were negative. That's basically the same answer. That's basically the same answer. You're just multiplying by negative. It doesn't matter if it's on top or bottom. So both of those answers would have worked. So here we didn't multiply by the conjugate, we just multiplied by I. Okay, number 6. Okay, 4 over 3 minus 5I. Here the imaginary number is in the denominator, and there's two terms. So we have to use the conjugate. We can't just multiply by I like we did in the last one. Here we have to use the conjugate. So this is going to be 3 plus 5I okay, the top, 4 times 3 plus 5I all over, all right, 3 times 3 is 9, minus 25I squared. I squared is just -1. This is going to make this a plus. So 9 plus 25 is 34. Okay, and this is exactly why I don't distribute the 4. Why? Because this is an even number, this is an even number, this is going to cancel. 2 goes into 4 twice, 2 goes into 34 17 times. So here, final answer is going to be 2, 3 plus 5I over 17. Now, if we wanted it, I think this is fine, but if you want it in standard form, you could distribute the 2, and then write 17 under each. So, right, this will be 6, 10 over. So technically, to be technical, right, this would be the, I guess, proper way for standard form, right? Standard form. Standard form of a complex number is A plus BI. Technically that's right, but you know, if you can get here, I'm happy with this. I'm happy with this. Okay, number 7. Identify the most specific number set to which each of the following belongs. So 7A. Okay, this root 5 is an irrational number. All right, it's irrational, meaning this is going to return a decimal value that will never repeat and never end. It's irrational, kind of like pi, right? Pi 3.14, 5 is going to be definitely more than 2, but less than 3. So 2 point something, but it's irrational. Okay, here we have a decimal that dot, 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 right? It never ends. It never ends. But just because it never ends, this can be represented as a fraction, right? This is going to be 1/3. Right here, whatever this decimal is, like this √5 cannot be written as a fraction, right? No matter what two numbers I pick, I can't make a fraction that will equate to that. It's not possible. That's why this is irrational. This is rational. Right, it's rational. Right, if I take the set of all integers, right, that's what the bold struck z is. It's a set of all integers, negative infinity to positive infinity, all the whole numbers, including the negatives and 0. So if I take any one of these numbers, and make a fraction, then that's a rational number, right? That's what it means to be rational, is that I can take any one of these numbers and make a fraction. As long as I don't put 0 in the denominator. That's the caveat, is that 0 cannot be in the denominator. But any combination will make a rational number, right? B is a rational number. Let's see. All right, 24i. 24i. Immediately I see the I. This is an imaginary, I is an imaginary number, right? Because I represents square root of -1. Square root of -1 does not live on the real number line. So this is definitely a complex number. Complex number. 24i. And D, all right, so 15. So most specific, right? This is the most specific. Technically it's a real number. 15 is a real number. All of these are real numbers, with the exception of this one. Not a real number. These are all real numbers, but most specific could be a natural number, right? A natural number. A natural number okay, so a natural number, bold struck in, the bold struck in, it's all the counting numbers from starting at 1, 2, 3, 4, all the way to infinity. So that's what a natural number is. The counting numbers starting at 1 to infinity. I guess that's the most specific. Okay. All right, number 8. Plot each of the following numbers on the same complex plane. Label the point with the corresponding P, Q, R, etc. Okay, well our points are A, B, and C. So it's going to be A, 2 plus 7I, B, all right, too easy. We got 3 complex numbers. Here's the complex plane. So we'll call this the real line, the imaginary line. Okay, A, -2 plus 7. So again, the real part is your left and right movement. The imaginary part is your up or down. With, respect to the negatives, right? If it's negative, we're gonna go left. If this is negative, we're gonna go down. Otherwise, we go right and up. So, -2 plus 7. So this is gonna be -2 up 7. So there's A. B, right 8 down 2. So right 8 down 2. That's B. Then lastly, C. There's no real part, so I'm not going to go left or right. But I'm going to go down 2, because this is negative. So that's C. All right, number 9. Okay, I want to solve by taking a square root. Solve by taking a square root. All right, 8x squared plus 60. I want to subtract 60 from both sides. 8x squared equals -60. Divide both sides by 8. So x squared, that cancels. So 60 divided by 8. So let's see, 2 goes into 8 4, 2 goes into 60 30, 2 goes into 4 twice, 2 goes into that 15. Okay, we got -15 over 2. I want to take a square root. So x is equal, plus or minus. So the square root of -15 over 2. The negative can come out as I. So square root of 15 over the square root of 2. Okay, I don't want to leave a square root in the bottom, so I need to rationalize the denominator. So I'm bringing I out of the way for the moment. So I'm multiplying by root 2 over root 2 because I want to get rid of this. So this is going to be x is equal to plus or minus. So inside times inside, root 30 over 2 I. Okay. Number 10, -1/4 times x minus 5 squared plus 50 equals 0. All right, so we're going to solve by taking the square root again. I need to get to the x, so I have to start stripping away all these external pieces. So I'm subtracting 50 from both sides. This is -1/4. Equals -50. Multiply both sides by -4, right? I need to multiply both sides by -4. Negative and negative is going to cancel. The 4s are going to cancel. I can do anything to the equation as long as I do it to both sides. That's the rule. So I multiply this side by -4. Multiply that side by -4. I'm going to get x. Negative and negative is a positive. 4 times 5 is 20 plus 0. Okay, we're getting there. Square root. I want to undo the square. Anytime I bring a square root to the table, this has to be plus or minus. So plus or minus square root of 200. Okay, this is really 2 times 100. 100 is a perfect square, so that's going to be, this is going to come out as a 10, right? 10 times 10, there's my pair. So I'm going to get, let's go this way. So x minus 5 is equal to plus or minus 10 root 2. Right, the 10 comes out, the 2 stays behind. So I add 5. So to both sides. So x is equal to, so I'm adding 5 to this amount here, right? This is an irrational amount, so 5 plus or minus this amount. So 5 plus or minus 10 root 2. That one's not bad. I thought for sure we were going to run into a negative, like a complex number, but it undid itself, so that's nice. That is nice. Okay, number 11. Number 11 says, solve by factoring. Okay, step number 1, see if we can factor out a GCF. All 3 are even numbers, so I can pull out a 2 for sure. So if I pull out a 2, this is going to be 40, 19, 3. Okay. 19 is a prime number, 3 is prime, can't do anything. Okay, so AC method. 40 times negative 3, so 3 times 40 is 120, or 12, so negative 120. Right, 3, 4 is 12, the 0 is negative, and then negative 19. Okay, I need 2 numbers that multiply to make this, that add up to that. And since this is negative, one of them has to be negative. The big one has to be negative because this is negative here. So this is going to be 2 and 20, 2 and 60, 3 and 40, 5. 5 goes into 12 twice. 4. There it is, that's it. So 5 goes into 120, 24 times. And 5 and negative 24 make negative 19. That was the one. Okay, so I'm gonna factor by grouping. Factor by grouping. So I write the first and the last term. Then the middle term is gonna split into those 2. I'm gonna do, doesn't matter what order you put it in. 5x minus 24x. Right, again, I combine these 2, I get negative 19. So I could have put negative 24 here and positive 5 there. Okay, we split it in between the second variable and the operation for the third variable, so we split it down the middle. I want to factor the GCF out of both of these. So first I look at the numbers. I can pull out a 5. Then I look at the variables. I can pull out an x. So what's left behind? This is 8x, right? Because 5 times 8 is 40x squared. Plus 1, right? 5x times that gives me 5x. There's a couple ways of looking at this. I know for this to work that this needs to be there. Can I write it there right now? Sure, I could, but let's see if I can make it happen. So here, if this is negative, typically you want to factor out a negative because look, this first term needs to be negative. If I don't factor out a negative, then that means this first term will be negative, and that can't be the case, right? It needs to be positive. So I'm going to factor out a negative 3. So that's going to leave behind 8x, because negative 3 times 8x gives me negative 24. And that's exactly right, look. Then plus 1, right? Because negative 3 times 1 is negative 3. And that's exactly what I want. So in conclusion, because the parentheses match, that's one of my terms. 8x plus 1. The other term is the leftover piece. The leftover pieces, the 5x minus 3. That's my other term. So 5x minus 3. We can't forget about that because we pulled out a 2 in the very beginning. Right? If I forget about this and I try to FOIL this out, I should get that. So my first term, 5 times 8 is 40x squared. Well, it's not that. So I'm missing the 2. Okay, there's the factors, but we're not done, right, because it's equal to 0. So that means I need to set each of these terms equal to 0. This is going to be 5x minus 3 is equal to 0. Add 3. Add 3 to both sides. 5x is equal to 3. So x is equal to 3/5. And then 8x plus 1. So it's negative 1 divided by 8. Right, negative 1, I subtract 1 from both sides, divide by 8. So x is equal to negative 1/8. So these are my two solutions. Those are my two solutions. That's where this graph crosses the x-axis twice. Crosses twice.
Number 12.
Okay, 36x to the 4th minus 6x cubed minus 90x squared is equal to 0. GCF, right? GCF, what can I pull out of all three? First thing, I'm looking at the numbers. Is this divisible by 6? It is. So if I pull out a 6, then I can pull out an x squared. X squared is common to both, right? That's the smallest one. So x squared. So I'm going to get 6x squared. 6 times 6, 36. X squared times x squared is x to the 4th. Minus x. 6 times x, negative x is negative 6x cubed. Minus, it's going to be 15. Right, because 6x times 15 gives me 90. Equals 0. Can't do anything here. So again, AC method. Multiply these two numbers. So 6 times 15, negative 90. Negative 1. Okay, I need two numbers that multiply to make negative 90, but add up to 1. They add up to 1, a negative 1, so the big one's going to need to be negative. The big one's got to be negative, and they got to be relatively close, right, because it's negative 1. So, I mean, even if I did, start going down the list, dot at some point, we're gonna run into 6 and 15, 7, 8, 9 and 10, 9 and 10, 9 and negative 10 actually, so that's it. This is the one. Okay, so same story. I'm gonna write the first term. We can't forget about this guy. So let's just bring him down. First term, last term, split the middle term. So plus 9x minus 10x, split it down the middle. Factor out the GCF here. I could take out a 3 and an x. What's left behind? 2x minus plus 3. So 3x times 2x gives me 6x squared. 3x times 3 gives me 9x. Okay, again, I'm looking forward. I need this to be here. Right, I need it to be there. So this is negative. I gotta factor out a negative. A negative 5. So that's gonna be a 2x. Negative 5 times 2, negative 10, and negative 5 times 3. Right, they match. They match. So because the parentheses match, one of my terms is 2x plus 3. The leftover pieces are the other factor, 3x minus 5. And then don't forget about the original thing that we factored out, the original term. So all this is equal to 0. I have to set each piece equal to 0. So 6x squared is equal to 0. X has to be 0. There's no other way around it, right? Just in case you didn't believe me, x is equal to 0. 3x minus 5. I'm going to add 5 to both sides. So 3x is equal to 5. Divide both sides by 3. X is equal to 5/3. And then lastly, 2x plus 3. Subtract by 3. Divide both sides by 2. So x is equal to negative 3/2. So there are my 3 solutions. Okay, that was number 12. Let's look at 13. All right, number 13. The height of h of an object shot straight up at 80 feet per second from the ground after t seconds is modeled by this. H of t is equal to negative 16 t squared plus 80 t. Sketch the graph. Okay, so then answer these questions. First thing I'm thinking is I've got to find the vertex. I need to find the x-intercepts, maybe the y-intercept, but for sure the vertex and the x-intercepts. I think those, like I don't even know what I'm answering yet. But if I'm dealing with the quadratic, the very first points of interest are always the vertex and the x-intercepts. So I know that the x component of a quadratic can be found using negative b over 2a. Now granted, we're using t. You could use t if you want. Nevertheless though, whatever variable this is, it can be found using this method right here. So this is my a, this is my b. So negative 80 over 2 times negative 16. Negative on top, negative on bottom, that's going to cancel. 2, cancel here to make that 40. 4 goes into 16 4 times. 4 goes into 40 10 times. 2 goes into 4 twice. 2 goes into 10 5 times. So t is equal to positive 5 over 2. Positive 5 over 2. So that means, what was that, 4.5? 2 goes into 5, oh no, it's 2.5. 5 halves, 2.5. So that means here's my t-axis, here's my h-axis. So 2.5. So somewhere on that line is the vertex. Question is where? I have to take this number and plug it back into the original, the OG one. So this is, so h is going to be negative 16 t, which is this, squared, plus 80 times t. Okay, I'm squaring a fraction, square the top, square the bottom. So this is going to be 25, this is going to be 4. 25 in the top, 4 in the bottom. Okay, I can reduce this, right? This is really over 1. 4 goes into 4 once. 4 goes into 16 4 times. So negative 4 times 25, that's negative 100. Right, 25 4 times. Here, 2 goes into 2 once, 2 goes into 5, or 2 goes into 80 40 times. Top times top, 40 times 5 gives me positive 200. So 100, negative 100 plus 200, h is going to equal 100. So 20, I feel like it's right here, 20, 40, 60, 80, 100. All right, so quick recap. Here's my quadratic. I can find the x component of the vertex by plugging in the values, taking that value, plugging it back into the original equation, and that'll give me the y component, in this case h, which is right there. Next thing I want to do is find the x-intercepts. All right, x-intercepts, all I have to do is factor this, right? Put it in intercept form. Or put that in intercept form. So I can factor out the GCF. Take out an 8, negative 8. If I take out a negative 8, typically if this leading term is negative, you want to pull out a negative. So this will be negative 8 and a t. So what's left behind? T? No. 2t? And then, what is this? 10? 2t gives me that. And no, this is negative. So that's why you always check yourself. Negative and a negative make a positive. All right. Technically, I can pull out a 2, right? Because I didn't pull out the GCF apparently, because more stuff can still come out. So this is going to be, if I factor out a 2 again, this will be negative 16t minus 5. Which is a little bit better. That's a little bit better to work with. It's a little bit better. I mean, did I have to? It'll still work out. It's just, want to be complete. Okay. I need this to be equal to 0. So that way I can figure out where does it cross the horizontal axis. So I gotta set each of these terms equal to 0. Okay, divide by -16. Do I really need to? No, you could just look at it, right? T has to be 0. Right, two things being multiplied and they equal 0 has to be 0. And this is going to be plus 5. T is equal to 5. So what does that mean? When T is 0, when T is 5, so when T is 0, it starts off on the ground. And then when T is equal to 5, we probably could have assumed that, but you know, you never assume anything, just trust the math. Okay, now connect the dots. All right, B, what is the object's height after 2 seconds? Okay, if I trust the graph, 2 seconds will be somewhere right in here. But let's plug in 2 into the equation and see what happens. I probably could have used the factored one, but it's fine. So this is going to be so 2 squared is 4. 4 times 16, 64. Right, this is 2 squared is 4. 4 times 16 is 64. Plus 80 times 2 is 160. What was the factored version before? It was 16 t minus 5. Right, that's what it was. That was the factored version. We could have used this, right? Plugged in 2 here, and it would have worked out the same. It would have worked out the same. Okay, so after 2 seconds, we get 164, -64 plus 160. So it's going to be 100 minus 4, 96. 96 what? 96 feet. 96 feet. And that looks about right. That's 100. All right, how long did the object reach? How long did the object reach its highest point? How long? 2.5 seconds. .5 seconds. How high was that point? Well, we said it was 100 feet. How long did the object, after how long did the object hit the ground? After 5 seconds. Okay. Okay, moving right along. Number 14, last question. All right, a shoe company tests different prices of a new type of athletic shoe in different stores. The table shows the relationship between the selling price and the monthly revenue per store the company made from selling the shoes. Here's the table. Using a graphic calculator, determine the equation of a quadratic model that can be used to predict y, the monthly revenue per store in dollars, when the selling price is X dollars. Round the values to the nearest thousand. So it would be what, tenths, hundreds, thousands, so 3 decimal places. Then use your model to determine the price at which the company should sell the shoes to generate the greatest revenue. Okay, so first off, this is my X and this is my Y. So we're going to go to the calculator. All right, I'm going to enter So when you have your calculator, you want to do what? Hold on. All right, so when you open your calculator, you're gonna do home 1, because I want to start something new. I don't want to save. 4. So home 1, 4. I'm going to put my X column, first column as X's, second column as Y's, and then start transferring the information. Right, 80,
90, 100, 110, 120, 130, 9680, 10520, 11010, 10680, 10400, 93.
80. Okay, so think of it as like 3 parts. First part, I want to get my information into the table correctly. So step 1's complete. Step 2, I need to plot these points. How do you plot these points? Control doc 5. All right, 5 is data and statistics. So there are my dots. I need to label the axes, right? Y is the vertical axis. X is the horizontal axis. So that was step 2. Plotting the points and then labeling the axes. Step 3, give me the equation. The equation is going to be menu 464. So even if you can't remember the number, menu, I want to analyze the graph. We're talking about regressions and quadratics. That's what we're on right now, quadratics. So 464. So here is the equation that best represents the model, that best models it. It said thousandths place, so tenths, hundredths, thousandths. So 3 decimal places, so we look at that. If this number is smaller than 5, it is. So y is equal to negative 2.196 x squared plus, so 1, 2, 3, 4, 5, 4, 9, 3, 6 x minus 1, 2, 6, 3, 7. So this was A. What is the equation for the quadratic model? Right here. Okay. B, use your model to determine at which the company should sell the shoes to generate the greatest revenue. All right, greatest revenue is the vertex. The vertex, right? Whatever that vertex is, that's the X value that we're going to figure out. And that'll be, right? Because X is what we should sell, and this is the revenue. So I need the X component of that guy. So negative B over 2A. There's definitely going to be calculator work. So negative B, which is this. So negative 454.936 all over 2A. What's A right here? Negative 2.196. So negative B over 2A. Let's put that in the calculator. right, control division. So I want negative 455.936 over 2 times negative, actually, I bet it needs to be that negative. About to get an error. This is going to be 2.196. 103.81. 103.81. $103.81. If they sell shoes at that price, they should generate the greatest revenue. That's what the model tells us. Okay, that is 1 through 14 review. Hopefully you all figured it out. If you need any more questions, ask me tomorrow. Comment in the comment section. Be sure to smash the like button. I'll see you guys tomorrow.